Hello, everyone. Let's get going. Good to see you, Steve. So you were able to make it.
Yeah, I actually thought I was going to be out tonight. It's my birthday today, so I was meant to be going out for my birthday, but I'm taking it easy.
So you didn't get your drinking buddies to join you.
No, not so much that. It was just my wife. She wasn't feeling so well, so I said I'd rather come here and do this.
So happy birthday then.
Thank you very much.
Happy birthday, Steve.
So,
cheers.
Yeah.
I thought you'd prefer going to a pub to being
yeah, like unfortunately, meeting. Yeah, like here it's Saturday night, and obviously with Christmas coming, there's lots of activities going on. So yeah, so that's where I was like last weekend. So I was out. I've got a few more coming up over the next few weeks. But...
Good. Yeah, Raquel said he's not likely to make it today.
Right.
So I saw you kept improving your score to where you're like in the 30s now or 40s or something.
Yeah, I was about 40, but I think I've been slipping down because I haven't made any progress in the last week or 10 days or whatever. I just sort of got stuck a bit.
So I had a question for you on kind of one of the things that you had been talking about for a long time and finally sat down and tried to do use the reveal targets that you mentioned. So one of the things as I started to do it that I think you had highlighted it, but it didn't hit me until I started doing it, which is that it's on the 0th bucket that it gives you all of the 55 times 200 stocks, but for all 55 time steps of the previous date ID, correct?
That's right.
At the zero time step. So now, since you're stepping through each of the 55 time steps, so is it the case that, at least the way I thought about it, is to save the data that is there in the reveal targets at the 0th time step and then keep merging the data for the 200 stocks at each of the 55 time steps going forward? Is that how you do it, or is there a better way to do
it? That's pretty much what I do. Yeah. So you got 55 times 200, which is what, 11,000. So you got like the 11,000 revealed targets. So I keep. So like the training data, I get the training data, and then I get the new test data. And so like each new time step, I store the 11,000 revealed targets, and then at the end of that time step, then I merge those revealed dates with the test data that's come.
Right. Okay. So that's
and add that to the test.
Right. But you do the merging at every because every time step you are given. I mean, the API only gives you the next time step, right? So you will kind of merge at each of those time steps, the test data and the revealed targets, correct?
That's right, yeah. So like every 55 iterations. Yeah, so like if you have...
So, no, but do you merge every 55 iterations or do you merge every iteration? Because what I realized is if you, with the test, because the test only gives you one time step of 200 stocks, right?
Yeah, well, I actually do two things. So every 55 iterations of the loop, I take a new copy of the revealed targets, because as you say, like every 55, that there's the next date. So at that point, I take a copy of all of the revealed targets. Then at every step, I merge the test with that block, merging them on the date and the stock ID and the seconds and bucket. But I also, every 55, so like I have the training data and I keep appending to it as well every 55. So there's two things going on. So every iteration I merge the revealed targets with the new test, which adds the revealed targets into that time steps one for the model prediction.
Correct.
But I also use...
And also every 55 you also append it to train is the additional thing that you do. Okay, I hadn't thought of that. That's a good idea.
That's right. So as I can train models later on.
Okay, when you at whatever intervals you can have a kind of enhanced training data which you can then and do you merge again on the same three things, the date ID, stock ID, and seconds in bucket?
Yeah, that's right.
Okay. I think that's at least what I've started to do. I haven't done it yet, but because of this thing of you have to merge on every 55. You have to copy, like you said, on every 55 and then merge on every single step. That was kind of lost on me until I started doing it, but I just wanted to confirm that there isn't a better way and that's how to do it. Okay. And additionally, you also merge it with train, which is something I hadn't thought of because I hadn't gotten to the retraining part, but that's good thing to do as well. Okay, cool. At least I'll try that. So besides that, anything else that you've done which helps the overall thing, or?
So like the public notebooks that are out there, the ones like sort of getting the best scores, like they've added a few extra features in and stuff, but like they're all like using LGBMs. So if you do the revealed target thing, you get some extra features. And I also add the revealed targets into, like they do what you call it, like sort of creating like lagged features. That's the words I'm looking for. So like they do lagged features on the features that are in there. So I add revealed targets in there, so I get like lagged revealed targets and stuff as well. So I expand it slightly a bit there, so I get a few more features. And like if you do that, then you get slightly better than what the public's doing. But I've also trained, like TabNet models using like PyTorch TabNet. So so it gave me a reasonably good boost. So like with the LGBM, it's sort of the main model, and then the TabNet ones gives you like another boost. And then the reason that
does your TabNet model alone give you a pretty good score, or how does that do, just a TabNet model?
Well, compared to the LGBM, it's worse, but I can't remember what scores they're getting. Like, I'll check. Yeah, so it's slightly worse, but when you combine it, it gives like a good boost.
So the additional two things beyond are, like lag features or using the reveal targets, and then also the inclusion of the TabNet model.
Yeah. So like just looking at like the best models at the minute. Like there's sort of like 5.338 or whatever's sort of about the best score in the public. Just using like the LGBM, but like with the extra reveal target features, gets me down to about 5.336. And then when I add the tabnet in, it gets me to what, 5332 or something like that. The tabnet itself would probably give you like a 5.4. So yeah, like it would be sort of way down, but when you combine the two together, it gives you quite a bit of a boost on it.
Yeah, no, that's good to know, because I tried, utilizing the tenfold thing that I talked about, right? Like using not tenfold, 5 choose 2 folds from the TSCD or the stuff, and none of those gave me a boost. And I was thinking, as an ensemble, and I was thinking it's probably because all of them are correlated. I mean, they use the same LGBM approach, and whereas I think as we've learned time and time again, right? Like if the models aren't correlated, then even if the individual score is relatively poor, like 5.4, when you throw it in with the other method, it kind of improves the overall score. So
yeah,
I think that's good to train a tabnet model as well. Then that might be worth it, just to even throw it into the ensemble and see what it gives me.
Yeah, so like in the last competition that we did that was similar to this, the Ubiquant one, yeah, like the winner of that competition, they used like 5 LGBM models and 5 tabnet models. So like, yeah, like they just had those 2 types of model in their system, and that was all they had. Yeah, so like that's all I've got.
Yeah, based on your earlier comment, I tried, with different seeds that you had mentioned, and that didn't seem to. I mean, it all ended up at around the 5.39, but didn't seem to give me any better boost than that. So yeah, the tabnet idea is a good one, because those aren't hard to train, and probably I'll just train that and throw it into the ensemble. That would be great. It improves things a little bit better.
Yeah, I think so too. Steve, do you also use some sort of rolling window or expand window or some sort of window features for the feature engineering part, or the lag features here suffice?
I just use whatever's in that feature engineering in the main notebooks. So if you look at the public notebooks at the minute, there's one about like 10 folds or something, and they've added extra features in. So they have like rolling windows of like various time periods. I think it's like 2, 3, 5, and 10 time periods. So I just use whatever they have. I haven't created anything myself out of that.
Okay. So you referred
by
to.
the way, go ahead, Mike.
Yeah, I was thinking you referred to the 10-fold, the 10 split public notebooks that are there, right?
Yeah.
Yeah. Yeah, go ahead.
And by the way, yes, last week, as we were discussing, I think I would like to get your thoughts on that, Steve. I thought that, remember Rachel had asked the 21, and why do we shift or use a kind of the 21 offset? And I was thinking that it is because of the rolling windows he uses of 1, 2, 3, 5, 10. Because if you add those, that comes to 21.
I'm not entirely sure. I meant to look into it, but I never got around to it. Can you see my screen at the minute?
Yeah, we can see it. Yeah.
Yeah, so yeah, like there's a few 10 split ones there. I can't remember which is I don't know which is the original.
And it's the pound means and the other one was the mean one, the row mean one.
Yeah, they've all got the same code anyway. So yeah, like in their feature engineering bit, I've just copied this now exactly, and just added like a little bit to it. Yeah, somewhere down here. Oh yeah, so here. Yeah, so like there's their like features. Yeah, so like all they've done, they've added like this, I think it was like the 10 one they've added or whatever, so they've just extended it a bit. So like they've done that twice, which means you get like the extra features. So in here, into this list, so yeah, so I add revealed targets in here as well. I think it is. It's into one of those. Yeah, so it just extends it a bit. But yeah, with regards to the 21, yeah, so this is it here. I'm not entirely sure.
Yeah, I was thinking, or at least my thought was that, if you look at it, that corresponds to the size of the window you would need because of your rolling window, right? Because if you don't get the tail 21, then you wouldn't be able to generate the 1, 2, 3, 5, 10.
Right. Yeah, like I'm pretty sure that is what it is. It's like just giving you like enough extra data like during once you start getting like the test data in the loop.
Yeah.
Yeah.
So if you were to add, like another thing there, like if you go beyond 10, then you would need to expand the 21.
Yeah.
But as Akhil was mentioning, it's probably, I don't know whether it will help, but if at all, it might be more useful to add 1, 2, 3, 4, 5, or things like that rather than 10, 14. Because I don't know whether going back further helps or having more data about the near past helps, whether the whole thing matters.
Yeah, and like now, because of how late it is in the competition, I wasn't sure if like adding any like extra features or whatever is going to help that much. I was trying to expand the models that I use. So like, as I say, I've got like the LGBM and the TabNet, and then I was trying to add in just like a basic neural network into it as well. But unfortunately, so I created a neural network in Keras. But if you do that, the LGBM models won't train. As soon as you like load in like a trained Keras model, for whatever reason, LGBM stops training, which means, as I say, like I train LGBMs in the loop, and so it stopped me doing that. It wouldn't let me train them if the GPU was on. So I've had to change over. I've like rewritten it all now into like PyTorch, which I'm training at the minute. So
interesting.
Hopefully, like by adding in, like just basic neural network, it'll help me a bit. Yeah, because like somebody.
So what kind of neural network are you using there? Sorry, go ahead, Mike.
Yeah,
well,
that was exactly my query too.
Yeah, so back over here. Yeah, so somebody's put one up, but yeah, so this. Yeah, like this person here, they're just using like a really basic model, just a basic PyTorch thing. But like in Fast AI, they've got like Fast AI Tabular, and like so this model here, it doesn't do like any embeddings or anything. So I didn't want to use Fast AI Tabular just because it hides things a bit and stuff. So I wanted to use basic. But yeah, there was some article I saw which effectively like creates like a tabular PyTorch neural network, basically the same as like Fast AI would, but like just using PyTorch. I'll post a link to it. But as I say, I haven't used it yet. I'm still in the middle of like sort of trying to train it, but mostly, yeah, like this notebook here is quite good. It shows you sort of like the training and stuff, and shows you like the learning rate coming down, and then it has other graphs and things in it. Yeah, so I don't know, like, will this help me or not? Like, I imagine, like, yeah, like the score of this one. Yeah, so you can see like the score's not that good on this, but like this one here, it doesn't even use any folds or anything. It's just like a single model and like not trained for very long. So I'm hoping if I sort of train like 5 or 6 of these models on all of the data, yeah, like using a sort of more advanced neural network, that I can like get a better score, and again, like just with the TabNet, get a boost from using this.
Yeah. Good idea. Especially if you use embeddings and stuff, I think that would provide the additional. Yeah, it'd be great to look at the article, because I think I would also like to create a, what you're doing, which is create a fast AI tabular equivalent, but not using fast AI.
Yeah.
Yeah, but I was going through the tweets on the X platform, the Twitter platform, and many of the guys that say that over time, XGBoost or Cat Boost or this GBM has the the highest score in time series as compared to the deep neural networks, in the PyTorch or the TensorFlow side. I was wondering if the score would match or even surpass that of the tabular methods, which are classically proven to have a high score here.
Yeah, like certainly, like in the last competition, I used like deep neural networks, and they gave me better scores than the LGBM ones. But yeah, they were maybe more sort of, I'm not sure, like maybe they'd overfitted onto the data or whatever, because when it actually came to like the private bit, they maybe weren't so good.
Okay.
But yeah, I thought I had a link to the article that I got this code from, but I can't find it at the minute. Yeah, I'll take a look and post it up when I'm done. The other thing I've noticed though on this competition, have you seen, yeah, like all my models, yeah, you can see my submissions. I was like putting submissions in and like they were all failing, and I hadn't realized that yeah, like they'd updated the data again on the competition. Like they'd released this like second lot of data.
Oh, they changed it again? I haven't submitted in a while. So what do you have to do now to get around this?
Well, yeah, so like previously when they released the first lot of data, yeah, so they added that flag in, this currently scored flag. And so yeah, previously my models started failing at that point because of the fact that my code didn't recognize the flag and so fell over. This time my models started failing because of the fact they've added like a load more test data at the end. And so yeah, like although I was just ignoring this flag, I was like recognizing it was there, but I wasn't paying any attention to it. And so like it meant you have the current public leaderboard test data, and then you've got like 2 sets of hidden test data. So as I say, like I train models as I go, and I was like training models on this data, and because of the fact that that set of data like had doubled in size, I was training like loads of redundant models, and so like all of my notebooks timed out. So yeah, so like basically I've just implemented now to recognize this flag, and when the flag is set to false, then I don't train any models. But yeah, like going forward, it's maybe a bit awkward to know exactly what to do, because they say that what's going to happen is the data that's used at the minute for the public leaderboard it'll not be scored in the private competition. So like this flag will get set to false. So you're going to have like a block of data at the start. So like the data that follows the training data, it'll all be there. The data from whenever it is, like August up to the 20th of December, all that data will be there, but you're not being scored on it. And then from the 20th of December, once the competition sort of begins on the private stage, all of that data you'll get scored on. So like if you want to train models in Loop, you need to sort of decide if you're going to do it, at what point you're going to start doing it.
Yeah, so wouldn't it be, but thinking of, yeah, I've read that, but I didn't know they had updated it yet again. And I changed my code to follow or use the, whatever the current thing false, because otherwise without it was failing. So people had added it. So I kind of followed their lead and put it in. But to your question about, now I understand better the interim data, at least what they're trying to do. They're basically saying the private data that they now use to score us will no longer be used to score, and it will continue to be there because it provides the continuity, if you will. So wouldn't it be better to, especially for the training part of where you merge, to continue to include that data in the and merge it with the train part, at least, so that that train part is continuous, starting in whenever it starts currently, and includes the missing chunk, which would be whatever, August to December, and then incrementally add to that as you move forward? Or are you thinking you will skip that data in train and then just add the wherever the train data ends now, and then jump or a skip and start appending or merging, starting with when the competition begins?
No, yeah. So all of the data, like I'm adding all of that into my training data. So you can see here. So yeah, you've got like the first set of data, which is the standard training data. So like say I've got like 5 LGBM models trained on that. Like that's the base of my notebook. And then right. You've got like the public leaderboard data. It's the second chunk. At the minute, so so this bit here, it's the bit that's being scored on to get the public leaderboard score at the minute. So as I'm like working through the loop of this, I add each new row onto the original training data. So I'm expanding the training data, but I'm also every 10 date IDs, I train a new LGB model. So the number of models I have is increasing every 10 days at the minute, which is okay. And then you've got like these 2 new chunks of data, which are there and like they're continuous onto like the training data. So I'm still adding them onto the training data, but I was also like making new models with this data, which at this point here is useless. There's no point doing that because of the fact these models aren't being used because of the fact it's after the public score. But then once the private leaderboard comes in, all of this data here, it'll still be given to you. And so yeah, like I'll still append that onto the training data to keep expanding the training data. But like none of this is scored on. So the scoring will only start here. Like this is the data that's going to come at the end after the 20th of December. So at this point in time here, I will have all the training data, but it's just a question of should I keep on making new models every 10 days over like this lot? Because if I do that, then I run out of time. Or should I just, at this point here, like on the sort of the first day that the private leaderboard competition starts, at that point there, should I just use all the data that's gone and start training models from this point? So
yeah, I think the key is because you're training it at every 10 data IDs, so you could potentially switch to just training one model on all of the these second, third, fourth unscored dates, and just use one model for all of that, and then incrementally train for the private at every 10 steps, or something like that, right? So that you don't incur the costs or the time penalty of 10 dates increments for the data, which is anyway going to be not scored, but given to you in one chunk, available to you at one chunk.
Yeah, so like it's a trade-off between sort of getting as many models as possible, but like fitting it into the 9 hours. And the other thing is, well, obviously it's hard to tell at the minute because of the fact that, there's going to be, 3 months extra data stuck on the end.
Right.
So yeah, it's just...
Yeah, in fact, I noted that down because some people, again, as I was thinking about it and I jotted it down somewhere here, that I think eventually the number of data IDs that, here, I have it here, 63 days is what we'll get exposed to in the future training. I mean, not future training, future private scoring. But currently, what we are being scored on the private is only 46. And the reason that matters is because you'll need to scale your runtimes by whatever 46 to 63 ratio in order to judge how much your runtime is going to expand just because the competition is running for longer.
Yeah, so you've got that, and then you've also got the fact that you do have extra training data if you want it. So just need to be careful that you don't use too much of that training data and slow your models down too much.
Yeah, but by the way, on that question, on that thought, do you cull any of the old data when you train the new model, or do you train on all of it?
No, like I have a limit. I can't remember what it is, like 600,000 rows or something. Yeah, so like once I get that, then I start dumping the oldest data and just use the newest stuff. So yeah, like like I reach a point where I'll not use all of the data at some point. The older stuff will be dumped, and it'll only train on the latest data.
Okay.
So the data is increasing all the time, or it's like culling the last one and increasing the data of the new ones?
Yeah, so you've got the training data, and then at each iteration of the loop, you get some more data, and that's what we were saying about the revealed targets. So as each new date comes, you can find the targets for the previous date from the revealed targets. And so, yes, so I use that to continuously add to the original training data and build it up and up. So like I get more and more training data as the competition goes on. And then I I create new models with that. But yeah, so like eventually, if you were to use all of the training data plus all of the new data that you're being given, the training time would take too long. So that's why I start dropping the old stuff.
But won't the accuracy increase here with respect to, suppose I don't have much experience with the light GBM part, but in DNNs the accuracy will certainly increase with respect to the amount of data that we put in. So I was wondering here, why doesn't it follow the same pattern?
Well, it does. Like the LGBM will get better the more data you give it, but the more data you give it, the longer it takes to train.
Okay.
And
sorry, go ahead.
Yeah, so so you could like train a single LGBM for a long time, whereas at the minute, like, so at the start of the private data, I could take all of the data that's gone before, which is like a load of data, and just train a single LGBM for a long time and get like a good accurate one. Whereas, like I'm creating lots of new LGBMs every 10 time periods. So again, it's a trade-off. Like you might get better results if you do just train one big one for a long time. I'm not sure.
So
you could do the
smaller,
combination too, right? Like you can train every 10, and then you can, like when you get to, I don't know, 30 or something, because 63 is the maximum, which is halfway there. So when you get halfway there, then you can train one on.
Yeah, you could, but yeah, as I say though, it's just hard to know exactly if your notebook is going to fit into the time. So,
that's the problem. By the way, the one thing I realized, and I wanted to get your take on it, and based on last week Rachel's discussion and stuff too, is even if you don't train the new model, but just use the revealed target features and expose your already trained LGBM models to those new features, the score ought to improve. I didn't know, for example, even though I've used LGBM in the past, and it's like a duh moment for me at least, that LGBM models can use features that they have not been trained on the fly.
All right, I didn't know that.
Yeah, that was something that I just found out this last week. I was like, oh, really? Because that's not at all like the DNN stuff, right? If DNNs haven't seen something and you suddenly expose them to it in inference and stuff, they don't do squat. But LGBM models, if they have not, for example, seen the reveal target feature, and you still have a reveal target feature, they still use that, which was something that I learned. And I was like, oh, that's interesting. I wouldn't, that was not obvious to me at all. Or at least I thought I was like, oh man, I've been dumb. I didn't know that LGBM could do this. Did anybody else know that already, or?
I didn't. Do you know how they do that?
I think it's just the fact that at the end of the day, LGBMs are basically, whatever, the forest kind of approach. So they just use that additional feature as something else that they can they can use to determine when and which path to follow as they divide. At least that's my intuitive understanding. And the way I found this out was the Rakel trick of asking ChatGPT the question, and it gave me the answer. And I was like, well, I don't know whether to believe it. So I went and looked around, and it seems to be the case that it's correct.
Oh, interesting.
Yeah, that was something that was.
I didn't know that, but I saw you're meant to be able to like sort of retrain the LGBMs. So like obviously I've got like 5 fully trained ones, and then maybe rather than retraining brand new models, maybe I can, like I think you can just sort of take new data and expand, like sort of fine tune them. So perhaps that would be another approach, because it would be like faster.
Yeah, that's where I was thinking that of trying that first, which is not incrementally training any new models, but just throwing in the reveal targets as I move along and see whether the score improves even by a little bit.
Yeah.
By doing that. So I'll let you all know whether that works, because my first attempt was going to be just that. Just get the data and then expose the reveal targets to the ensemble of models and see whether that improves my score, even just by a little bit, because that would be confirmation of, what ChatGPT and other search tells me, that LGBM models can use features that they have not seen in training. That itself was like, whoa, something new, but worth learning. If nothing else, I'll take that away from this competition.
Yeah, like I don't even need a model that can take new features, because all of the features I'm getting in the loop are features that I have been trained on. But yeah, like if I could take a pre-trained model and fine tune it on the new data to make it better, then that would speed things up considerably, because as I say, like every 10 time periods at the minute, I'm training a brand new model from scratch, which takes a long time. And so, yeah, like if I could just take my existing trained models and fine tune them with the new data to make them a bit better. But yeah, like, as you say, like every 30 days or whatever, train like a big new model, then yeah, like that would give me the time to do it within the loop.
So do you use a big model and a combination of I mean the ensembles of smaller models here?
So I've got like something like 10 pre-trained LGBM models. Like 5 of them were trained on the folds from the original notebook, and then 5 I trained with random seeds on all of the training data. So I've got like 10 pre-trained LGBM models, and I've got like 5 pre-trained TabNet models. But then within the API loop, as I get new data, I would create a brand new LGBM model every 10 date IDs and add that to the set of models. So yeah, like the number of models I have is continuously increasing as the test API goes. So yeah, like I just get more and more models in the ensemble. I just add that to the ensemble. Yes, like that's another thing. It might be that as I get new models trained on the new data, maybe I should drop some of the old ones.
Okay, so that's a nice interpretation of how this workflow works in practice. Thanks. And plus, with respect to the DNNs one, I was thinking, I just searched on the Conrad notebook, the one which we talked about in the earlier parts of this stock market session, and I think so his 6th part, that's the deep learning for the time series sequences, in which he uses the RNNs, that is the GRUs and the LSTMs. So he had that implementation there. I was thinking maybe we can use or understand from that part to transfer it to the DNN part as well. So there might be 2 parallel ways that can that we can reach the same threshold, as to speak.
Yes,
Yeah,
certainly.
Go ahead, Steve.
I was going to say, like in the last competition, the Ubiquant one, yeah, like I had RNNs in there and GRUs, and was it 1D CNNs I had? Yeah, like basically I was like sticking as much in as possible. It seemed to be the more you added, the better it was. But
yeah, actually, I was going to say that beyond RNNs, the other, in fact, there have been much like in language and stuff, RNNs for time series have been superseded by transformers for time series. So there are multiple transformer models now that you can use for time series. But all of them are more complicated than what Steve is trying to do, which I like, because the simplicity, in fact, where in this case, I think it's just the non-correlated errors that you are likely to see. So the simpler that you're likely to benefit from when you throw the model into an ensemble, because anyways, you're not going to switch to just a transformer model, because I haven't seen any deep neural network model do as well, at least in this competition, as the LGPM-based model. So if it is an ensemble, then the simpler the model, the faster it will train and the less compute load and all that. And so if you follow that line of thought, then you're better off using what the approach Steve is doing to just get a simple model, maybe with embeddings, and then just throw that in along with your other models as part of the ensemble.
Yeah, so like apart from having like the sort of the windows and like the lagged features there, I'm not really treating this as like a time series problem. I'm just treating it as a tabular problem.
Nice. So this, the link that you have shared, it's behind a paywall. It's behind a paid. Yeah. So do you have a free one? For the members only story, that's the stuff that it stays on the paywall.
All right. I'm not a member.
Okay, but you can see it, right?
Yeah.
Ah, nice.
I don't know why. Oh, sorry. I don't know. I'm not sure why. Do you not get? I thought like towards data science you got like 3 free a month or something.
Ah, okay. Yeah, that might be the reason. I might have expired my the free stuff. Yeah.
I think it is, yeah, because like if I look at this like after like a few in a month or whatever, then I hit that as well. But yeah, I'm not sure. Try logging in as somebody else or use a different browser or something might get you in.
Yeah, one thing my kids taught me was to try incognito. Sometimes that gets you past.
Yeah.
Yeah, I've tried with this new medium paywall stuff. It's everywhere. I've tried the incognito, I've tried different browsers, I've tried new tabs, in incognito mode, and everything. But you will have to pay to get more views.
It may be they go by the IP address kind of stuff too. So
yeah, they have upgraded their yeah.
And sometimes, I mean, of course, if you have VPNs, but then they block all VPNs anyway.
Do they?
Sometimes some of them do, like subscription services. I was paying for it. I was paying for YouTube TV, and I was in India, and they block it. Using a VPN, and they block.
All right. Yeah, because I was having trouble connecting to something, so there's like a free VPN that you can fit into Chrome. So I started using it, but I haven't used it to try and get on Medium. But yeah, like it maybe is what region you're in. I'm not sure.
Yeah, they block by region. Yep.
I didn't know they'd be able to tell if you're using a VPN.
Yeah, Netflix.
Somehow they figure it out.
Yeah, Netflix blocks by region, but I'm not sure about Medium.
Yeah, I've just put a link to like it's a free VPN that I use. I don't know, like with that. Yeah, like you can, if you don't go the paid option there is some free version of that. Yeah, so I just use the free version on that. I'm not sure if that would get you by it.
The best one I found when I was using one was the ExpressVPN part. The ExpressVPN one. It had connectivity to UK, to US, to most of the countries, and to Singapore, and it allowed me to watch those shows. Like in UK, there's the Doctor Who in Prime. Yeah, in the Prime video streaming network. So I was able to watch those series, but uh, while connected to US, I was able to watch some of the movies that weren't released in India. So I had some experience with that.
Yeah, so I hadn't realized. Yeah, as I say, like I think I can see like a few Medium articles for free each month, and then I start getting asked to pay for it. But...
Okay, any luck or anything, any attempts, Emily or Terence?
No, I haven't been able to.
Yeah, I've been playing around with one of, I didn't really get far starting from scratch. I don't think I have a lot of time these days, but I was trying with the Optiver robust best single model notebook, public notebook. So far I think I've only made it worse by tinkering with it. I'll try going the other direction on some things.
Did you get a submission from it?
No, not yet. It looks bad enough that I didn't think it was worth it.
Right.
Mehul, did you try anything at all, or are you just kind of following along to see what's happening in the tabular space? Just keeping him busy, probably. Okay, any other questions? I guess we have one more week, right? Next week we aren't done. And I think 20th is the last day. So we have one more week. Right. Yep. So yeah, lots of stuff that I have to at least attempt. Ideas. All right. Anybody else have any other questions?
I don't.
If not, enjoy the rest of your birthday, Steve.
Yeah.
Thanks very much.
See you next week.
Okay. See you next week. Have a good week.
Take care, everyone. Bye.
Thank you.
See you later.
Bye.
Bye.
Take care. Bye.